All right, let's see if we can get through these three examples without making any major mistakes. What I'm going to do is I'm going to, first of all, square both sides. Each side has a square root, so squaring will get rid of those. So we will wind up with 3x minus 1 equals 5 minus 6x. By the way, I could do this. It would be nice actually to see this on both sides. Anyway, at this point, I'm going to add 6x to both sides. And I'm going to add 1 to both sides to get the variables on the left, numbers on the right. And you'll notice I am skipping steps here because we've done linear equations a long time ago. And x would be 6 over 9, dividing both sides by 9, and simplifying and getting 2/3. I've said that whenever you are squaring both sides, we need to verify. So let's check the left side is the square root of 3x minus 1 equals 3 times 2/3 minus 1. Make sure that goes over top of that. And 3 times 2/3 is 2, minus 1 is 1, so square root of 1, which is 1. The right side of the original equation, let's go back up to the top, is the square root of 5 minus 6x. Let's put 2/3 in for x. And it's okay if you do these calculations like that with your calculator, no problem with that. Anyway, we wind up with the square root of 1 again, which is 1. And we know that left side is equal to the right side, therefore our answer of 2/3 is a solution to our original equation. Now this one is actually, again, pretty straightforward. The thing is, we don't want two things on one side. So what I'm going to do is I'm going to add that to both sides, which will give me 4 cube root of x plus 5 equals cube root of x. I've added cube root of x to both sides. At this point, I now have 1 cube root on each side, and I'm going to cube each side. So 4, and I'm going to do this. I'm going to put the cube just to show what's going on. This is really nice if you can do this. And I'm going to get 64, 4 cubed, and then x plus 5 equals x. I'm going to expand. I will subtract x from both sides and subtract 320 from both sides. And then I will divide both sides by 63. And I will get that x is, when I put that in my calculator, I get negative 5 and 5/63. Or, if you want to write this as a decimal, it is, I believe, negative 5.08. And because it's a cube root, you do not need to verify because cube roots and cubing do not change negatives into positives. So unless you're asked, you do not need to show the verifying. Now this kind of a question is literally the toughest kind. Although it's not that difficult, it's just that there are two major steps. You will notice that we have a square root on both sides, but we also have this, which makes this left side into a binomial. And if I put that on the other side, I would still have a binomial. And when I square binomials, I have to do FOIL. So this one for sure, I'm going to do this. And when I square the left-hand side, the first term squared is simply x minus 2. The outside and the inside are both root x minus 2, so that's going to make plus 2 root x minus 2. And then the last, as in FOIL, is 1. The right side squared is just x. Next step is isolate the remaining radical. I'm going to, first of all, subtract x from both sides. When I subtract x, those are both gone. I can either combine those two first, making them -1. Bottom line is I'm going to wind up adding 1 to both sides. I'm going to wind up with that. Okay? At this point, I can leave the 2 where it is, or I can divide both sides by 2. It doesn't really matter. Then I'm going to square both sides. For x minus 2 is 1. X minus 2 is 1/4, dividing both sides by 4. And then x is 2 and 1/4 after adding 2 to both sides. Now we need to go back up to the very original right here and verify this. So the left side is the square root of x minus 2 plus 1 equals 2 1/4 minus 2 plus 1. This is the square root of 1/4, and the square root of 1/4 is 1/2. So at this point, I'm going to say this left-hand side is 1 1/2, or 1.5. Well, the right side in the original equation was the square root of x, which is the square root of 2 1/4. And when I do the square root of that, I get 1.5, or 1 1/2. So my final statement is left side equals right side, therefore x does in fact equal 1.5, or I could have written 1 1/2.